Hi, and welcome back to my C# OpenTK 2D Game Engine / Framework series. This is part 5, where I'll be covering textures. Textures allow us to display images in OpenGL. I will also introduce a new buffer type called an element buffer object. Since OpenGL natively draws exclusively triangles, we need to use these to turn our triangles into a rectangle. OpenGL does support drawing what's called quads, which, as you can imagine, is a rectangle / square. While you can use this, this is on its way to becoming deprecated. And if I've read correctly, OpenGL turns them into triangles under the hood, so we might as well remove that overhead and do it ourselves. For a 2D game, you could probably get away with just drawing quads. However, this is more about learning, right? So if something that's worth learning, I think it's worth learning to do correctly. So let's get started. If you remember from the last episode, we got shaders in place. We were able to draw this triangle and set the colors. I think this is a good breakpoint for this file because it contains a lot that we can go back and reference. So the first thing we should do is let's create a new implementation for the textures. Let's add a new class and call it texture test. Go ahead and click add. And to save ourselves some time, just follow these steps closely. Go into the original test game, hit Control A or select all, and then hit Control C to copy. Go in here, hit Control A, hit delete, and then Control V to paste. And let's just rename this to texture test and also update the constructor name. That should take care of all of our build errors. And then go into program and let's change this to texture test. Let's run this and make sure it looks the same. And it does. Alright, so now that we're done with test game, let's take a look at texture test here. We're going to get rid of these colors, but we need to replace it with what's called texture coordinates. We also need a ability to load textures, and then we also need to introduce the element buffer object. I think let's start by getting this triangle to turn into a square. Let's start by taking a look at our normalized device coordinate system. So today what we're doing is we are drawing a triangle. So we have a vertex here, we have a vertex here, and then we have a vertex down here, and then that creates our triangle. But instead we want to draw a square. So the way we can do that is we can break up these, we can create two triangles to create a square. We have one triangle that is this direction and one triangle that is this direction. And then we can use the element buffer object to index into these individual vertices to create our rectangle. So you can think of it like this. Let's say this vertex we want to have start at the top right. So we start here. Let me go ahead and mark this. So we start here. Then we want to go to the bottom right, which is here. And then we want to go to the top left, which is here. And then I'll go ahead and fill this in with red to represent one of our triangles. Okay, so that's one of our triangles. And then now if we look down here, we only have one that's unique. It shares the same vertice as these here. So we can start by putting on our, we'll go switch this to green. So we would start on the bottom right, doesn't matter where we start technically, so we'll start on the bottom right, and then we will go to the bottom left, which is here, forgot to fill this in over here, and then we go to our top left, and then that creates our second triangle, and out of that we get a full square. Go ahead and just fill this in with black, and then we have our square. So we can do that by introducing the element buffer object, and I'll show you how to do that here. For the sake of time, go ahead and head down to the description and copy the code that I have for these vertices and go ahead and paste them in right here, and let's go over them. So we have our square that we're defining in our vertices. This would be our top right vertice, and we're making it, well, it should be red. This is red. And then we have our bottom right, which is green, and we have our top left, which is blue. And then we have our top left, which we're going to make white. Let's actually just make it white. And when you copy and paste these in, it'll have the correct comments here. So then what we need to do is we need to keep track of these. We need some way to tell OpenGL how do we want to draw these, so that way we don't have to create a triangle and then another triangle and keep track of this. We can just index into these to create our triangle. So what we would do is do a private uint array. We'll call it indices. So we want to start at the top right, so we'll do 0, and then from there we want to go to the bottom right, which would be at index 1, and then from there we want to go to the top left. That put us at index 3, and then this is our first triangle. And from there we want to start from, I guess it doesn't really matter, we'll start on the bottom right, so we'll do 1, and then we want to go to the bottom left. So that would be index 2, and then we want to go to the top left, which is 3. And I need an equal sign. Okay. So then now what we need to do is create an element buffer object. Can't forget our semicolon. So we'll do the same thing we did here. We will declare a private int element buffer object. And down here we will keep our default shader. Does that do the linear interpolation? Yeah, so we have an invec3 and an invec3 for our position and color, so we don't have to change that. We won't have to switch up the shader any, so that should be fine. Yeah, we'll still call compile shader here. And then down below, after we have declared our vertex attribute pointers here, we can say element buffer object equals gl.genBuffer, same way that we did for our vertex buffer object. Now we need to bind buffer, so we say gl.bindBuffer. Our buffer target is the element buffer object, buffer target.element buffer array, and then the element buffer object. And from there we want to bind or set the buffer data, so we'll do gl.buffer data, and we have to specify the buffer target to the element buffer array. It'll be indices times indices.length, so that would be up here, so the length of this times the size of a unsigned integer. And give it the actual data, which is indices. And these will be a static draw. These will not be changing. Static draw. Okay, and then from there, we can keep everything else the same, because our attribute pointers have not changed in size. Okay, so instead of calling the draw arrays, we're going to call a different method called gl.drawElements. So this is going to draw this element buffer here with the vertices that we have supplied. So it would be a primitive types.triangle still, because natively this is what it's drawing anyway. As you can see, there is a quads option, just to show you really quick. See, we have quads. You can also do a triangle fan, which I know can be used to create triangles, but we're going to stick strictly with triangles. And we'll use the indices.length, which is the count, because that's how many that are being passed in. And the size that is being drawn is an unsigned int, so we'll do unsigned int. And then there is no offset. We're just starting at 0. And if we did this correctly, we should see a square or a rectangle. And there we go. We got the white and the red, the green, and the blue. Okay, so that's great. Now we need to add our textures. So instead of supplying these colors, we're going to supply texture coordinates. Now, texture coordinates work similar to the normalized device coordinates system, right? The only difference is this is the only thing that exists for texture coordinates. I'm gonna do some cleanup here. Don't mind my nasty paint skills here. Your value can only be from 0, 0, 0, 0 to 1, 1. There is no negative in texture coordinates. So typically if you've ever worked with sprite sheets before, you know that you can use the number of rows and columns and do some division. You can get the actual record. Well, that's going to work a little bit differently now, because instead of the top left in a sprite sheet being 0, down on the bottom left is 0, and you're working your way up. So let's go ahead and work on getting textures added, and we're not going to hard code this directly into our load content method or anything like that. We're going to start off by just abstracting this out into its own class right away. And the reason I want to do that is because I want to start getting into resource management. And when we start loading in different types of resources, we want to have a clean way to handle that. So we're going to start off by creating our resource manager and then have it load our texture. For now, we can create a texture 2D class just as a placeholder. So we'll call it texture 2D. Add this into your rendering folder. Go ahead and click add. And it can stay in the rendering namespace. We'll just make it public. Remove the using statements. And now we can create a new folder or namespace in core, and we will call it management. And then let's create our resource manager. Resource manager. And we're going to want this to be a singleton class. We don't want there to be potentially multiple instances of this, even though it's going to be static. So let's take care of that first. We can make this public, and then let's make a private instance. So private static resource manager, we'll call it instance instance. Wow, okay, equals null. And we're gonna, in the event that we're going to use some multi-threading, we should probably add a lock for this as well. So private static read-only object lock. Just call new on that. And then we're going to want a dictionary for a texture cache. So this way we're not loading them from a file multiple times. The dictionary, we'll just use the name of the asset as the key. And we'll need a texture 2D. Bring in the namespace for that. And we'll just say new. Can I just do that with this? Nope, looks like you can. That's fine. New dictionary string texture 2D. And then let's create our instance for it. That's right, we'll want to name it texture cache. And let's get a public static resource manager instance, and then we'll only have a getter for this, so make sure we lock it, so if we have anything trying to access multiples of these, we don't cause a run on race condition. Say instance equals new resource manager. I think maybe we want this to be a sealed class. We might come back and change that, but let's make it sealed for now. And then we'll return instance. Oh, I spelled something wrong, I assume. Oh, no, I get it. I need to lock the lock object. Yep, and then check if instance is null. I get you. That's when we'll set this here. Otherwise, if it finds it, we're just going to return instance. There we go. And then now let's create a method that's going to load the texture for us. So we'll make a public texture 2D, load texture, string texture name. Now keep in mind that when we pass in the textured name, that's going to have the fully qualified name. So if we create in resources images, the texture name will be resources/images/texture.png or whatever the file name might be. So just want to call that out, that you cannot just simply pass in the name of it. We do that because eventually we might just make an asset cache instead of just specifically a texture cache, and we'll have all of these assets that can be loaded from the resource manager inherit from some kind of base class. So this way it doesn't have to decide, but just want to call out that we might change it to do that later, and that's why we're going to use fully qualified names. This way we don't potentially create something with the same name. I can't think of any instance where that would happen, but it would still be possible, so we want to make sure we prevent that. So we'll go to texture cache, and we're going to try to get value from it. We'll get the using texture name. We'll do out var value, and then we will, what's wrong with this? Out var value. Oh, yep, that makes sense. This is not, it's our out variable, so if value is not null, we can return value. Sure what I'm doing wrong here. We'll come back to that. Otherwise value, and we're going to need to create a texture factory to load this. So let's leave this blank for now. Let's figure out what this issue is about. So we have public texture 2D, load texture, string texture name, texture cache dot. Oh, I get it. I tried it. Should we try get value, not try add? Try get value. And then now let's create in our management namespace a new folder, and we'll just call this texture. So anything related to texture management in particular is going to take place in here. So we'll create a static class called texture factory in here. Texture factory. Okay. And now that that's created, what we'll do now is make this static. And I forgot. Let's go back to our resource manager. I always want to make sure we're cleaning up as we go. Let's remove any of these unused using statements. We don't need them. And we're gonna need a few things here. So one thing that we're gonna have to add is we're gonna have to go into our manage NuGet packages for core here, and we need system.drawing. So be system.drawing. I think it might be just called common, but let's see. So system.drawing.common. Yes, you'll want to install this. Unless you were on .NET Framework, it just comes with it out of the box, but this has to come in through a NuGet package. And keep in mind, I believe that the way that we're working with this is it's only going to work on Windows. We will add support for other operating systems down the road, but this might only work with Windows. I will confirm and get back to you on that in the next video. So public static texture 2D, and we can leave this in the management namespace. We'll bring in rendering here, and we'll have a load method. It would be take a string texture name, and we need a handle. So what we do is we call gl.gen. That's right, we need to import gl, which would be in the OpenTK gl4 namespace .gen texture. Should be just a gen texture method. Why am I not getting just gen texture? Oh, gen texture. Now give us a handle, and we need to set the active texture slot. Active texture. And one thing to keep in mind here is OpenGL, you have what are called texture slots. And that's all determined based on your graphics card. I don't know how many are on mine, but typically you don't want to load a bunch of textures into individual texture slots. I think if you've had any game programming experience before, you know that you would probably have sprite badges, right? Excuse me. You would have sprite badges, and you would have all of your animations in a single file and all of your tiles in a single file, and then you would index into those and create a rectangle and pull those out. So that's why you don't have to have multiple textures or a texture for every single animation, for example, or each individual tile. For now, we're going to just use texture 0. We will add support for multiple textures as we go on, but we can also store multiple textures in a texture slot. So you can create a texture array. And then that's what we're going to focus on, and not on this video, but in the next one. This one is just to get a texture on the screen. So we will call texture unit.texture0. And we need to bind it, so we do bind texture. And we need to go to texture target.texture2D, because these are two-dimensional textures. I believe there are several types. Let's see, what other kinds are there? And there's texture 2D, there's texture 3D, and texture 4D. I've never heard of those, but we're just going to work with texture 2D. And there's texture 1D apparently. And then we need to bind it to that handle. And then now we need to use the system drawing library here. So we can just do using var image equals new bitmap, and we'll bring in system.drawing, and we'll pass in the texture name, which will be the fully qualified file name. And from here we need to rotate it, because by default when this gets loaded in, it loads it in and it will be upside down, so we need to rotate it on the y-axis. So what we do to do that, we simply do image.rotate flip, rotate flip dot y, rotate flip y, rotate none flip y. That's what it was. And then now we need to get the bits or the data for this. So since C# is garbage collected, we don't know that the addresses, when we load something into memory, those could change. So we need to lock those bits into place in order to read these. So what we'll do is say var data equals image.lock bits. And then now we have to provide it the rectangle. So how much of this do we need to draw? So we need to do the full image in here. We'll just go ahead and start a new line. So we'll do new rectangle. We want to start at 0, 0, and then use the image width and the image height. So that means we will load the entire image. And then we need to provide it the lock mode. We're only going into read only, so we're going to do image lock mode. And to make things easier, let's add this up here. So we're going to do using pixel format. This will be for our next one actually, but we'll come back to that. So image lock mode dot read only. And then now this is where we'll want to add drawing.imaging, I think, for this one. That's the namespace it's in. That might be taking a guess here. So we'll be using system.drawing.imaging. Then that should bring in our lock mode. Yep. So now what we'll want to create is a reference to pixel format. So we're using OpenGL4, or OpenTK's OpenGL pixel format. So do using pixel format equals OpenTK.graphics.OpenGL4.pixel format. So then down here we will do pixel format dot format 32 bpp format pixel format dot format. I'm looking at the wrong one, aren't I? Hang on. System.drawing, rendering, OpenGL4. We do have it all in here. So we're using the imaging. Okay. We'll just fully qualify the name. You should have a way to do this without, but that's fine. So we'll do drawing.imaging.pixel format 32 bppargb. That would be why I see what we did wrong here. we'll come back to this here in a moment. After, let's get the texture loaded here. So we'll do gl.text image 2D texture target dot texture 2D, and our level, by default it's just 0. This will specify if it's this is where it comes into play where there's multiple textures, but now we'll just do 0 pixel internal format dot rgba image dot width image dot height, and we want no border, so we'll specify 0 so there's no border. We need to use pixel format dot bgra, and it's an unsigned byte, so we'll do pixel type dot unsigned byte, and then we need to provide the pointer to these bits, which we can use data dot scan 0, and then that will give us the pointer to that data. And now we need to clean this up a little bit because it's kind of screaming at us here saying that something isn't quite right. I'm going to pause the video and come back and we will get this fixed up. Okay, I see what it is. So the version we installed was version 6.0. So if we actually downgrade our version of system.drawing.common, let's bring this down to version 5. We'll update this. Okay. And then now these should disappear. Okay, so now it's no longer giving us the warnings about Windows. Perfect. So let's continue. So down here we need to tell it how is it supposed to handle rendering this texture. So for instance, when you're looking at an image, let me see if I can find a picture here we can use as an example. Yeah, for instance here, this is the Dwarf Fortress tile set. So normally there's some, I believe it's called anti-aliasing that's going on, where it's trying to round off the nearest pixel and make it so edge is a little bit smoother. That's, I believe it's called linear, but what we want is the nearest. Every pixel we're aiming for in here, this is kind of meant to be more of a pixel art based engine, but if you are not doing pixel art, you would simply change one of these to linear, and I will leave a comment here, but for now we're going to support it as if that we were trying to make something like an old school RPG game, over top-down RPG game, because that's probably what this engine would be best for, because it's not going to have any physics library built into it. You would need to add that yourself for your own engine, but let's go ahead and let's get moving. So we have gl.text parameter, and we need to tell it that it's texture 2D as the target, so texture 2D. And then texture parameter name dot texture min filter, and we have to convert this last one to an int, but it is the texture min filter dot nearest is what we need. Texture min filter dot nearest. And let's copy this for the maximum. So we just change this to texture mag filter, and we're also going to use nearest, and then we need to tell it how does it wrap the texture. So if we make it too large, is it supposed to repeat itself, or what are we supposed to do with it? Is it supposed to stretch it out? But we're going to go with repeat so it retains its original size. So we do gl.text parameter, and then we just the texture 2D, texture target.texture 2D, texture target dot texture 2D, and then with the texture parameter name is texture wrap s, and we'll just tell it to repeat by using texture wrap mode dot repeat, and we will do the same thing for wrap t. And then what we can do is we can tell it to draw or generate what's called mip maps. So what mip maps are is they take a texture and it will scale it down, and it will know to sample from a large texture or a smaller texture based on how far away it's being rendered. For a 2D game, we probably won't need this But let's just go ahead and do it anyway, just so we know it's there. This probably is completely unnecessary, but if you ever decide to expand on this, then you don't have to remember to go back here and update this to start accepting bitmaps. Because end of the day, this is a 2D game engine, but once this is all done, there's really nothing stopping you from changing this to be a 3D engine, because there really is no such thing as just 2D, in quotes. It's 3D being represented by an orthographic camera instead of a, what is that called, projection matrix. It's an orthographic projection. All right, so now we need to update our texture 2D class. So let's go back in here and let's make a constructor for it so that way it has the handle. So we'll do, let's see, for our texture 2D, it's probably doesn't, we'll just make it public. That's fine. So let's do public int handle. Public int handle. No, I don't know if we need to have a setter for this. I don't think we should, unless we want to change textures. For now, let's make it a private set. I don't think we need to allow updating it outside of the texture, so let's create a constructor from this. Generate constructor, that looks good. Let's move this up here. And we just need a method called use, similar to how we have for our shader. So public void use, and gl dot. We have to set the texture unit that's active, and we're going to set it to 0. So active texture is texture unit dot texture 0, and then we need to bind the texture. So gl dot bind texture. Texture target 2D, texture target dot texture 2D, and then the handle. Then we're not going to properly handle it in this video, but I do believe we need to do some cleanup, because textures, they use up quite a bit of memory here, so we want to make sure we're cleanly getting rid of these. So let's make it inherit from iDisposable. So iDisposable. And then we need to implement the interface. Let's do that. And then let's keep track of if it's currently disposing. So we'll do private bool dispose. This is pretty boilerplate stuff here. Disposed. And then let's make a deconstructor for this. So texture 2D, and we'll call dispose, and we'll want to pass in if it's currently disposing, so we'll create a method for that. So do public void dispose, and keep track to make sure if it is currently disposing. And then if it's not, hasn't been if it hasn't been disposed, we call gl.delete texture, and then we'll have the handle, and then we'll set it that it has been disposed. This way we can't call it multiple times. And then in our actual dispose method here, we will call dispose false, because it has not been disposed. No, true. True. And then we'll do the gc.suppress finalize this. This way the garbage collector can handle it. We gotta make sure we're calling dispose false here, because this is when it's being deconstructed. I think that about handles it. I think about it, maybe we don't even need this because we're not calling it. That's fine. We're not going to get too caught up into this because we're not going to be properly disposing these. This is just to kind of get some of the structure in place. So let's go in here and we will return a new texture 2D, and we'll pass in the handle. Okay, and then in our resource manager, we will simply call our texture factory. So instead, the value here will become this texture factory dot load, pass in the texture name, then our texture cache, we will add it using the texture name, and then the value, and we will return the value. So that should take care of loading the texture here. Now we need a shader. So what I find to be the easiest when it comes to shaders is just go ahead and take your default, copy it, click on the shaders, and then hit paste. And then we'll just rename this to texture, for texture shader. Also, very important, make sure down here you set the output to copy always. Wait, looks like it retained the value. Okay, so that is actually a nice little bonus I didn't even know existed. So if you copy an existing item and paste it in and rename it, it retains this copy to output. But there's one thing that, just to call out in general, is you always want to make sure that anything in resources is always set to copy always, because it can't actually build it or do any type of action like that. So a lot of this stays mostly the same. Obviously we're not going to pass in a color. Eventually we will. We'll have a texture with color GLSL script, but for now we'll just keep it as texture color to keep it simple. So instead this will become a vec2. There's only an x and y we need to pass in. There's no third, there's no z. Remember, with texture coordinates, there is only a value between 0, 0, and 1, 1. There's no negative and there's no z. So we'll turn this into a vec2, and we'll call it a text chord, and our out value will need to be we'll need to create an out variable for the texture coordinates, because in the main function it's going to determine what that is. So we'll call this out vec2 text chord. Save that, and we'll want to set our output variable to be just texture coordinate here. Yep, they're both vec2s, and this can all stay the same. Yeah, I don't think we have to change anything here. Okay, yeah, we'll leave that the same, and then what we'll need is the texture coordinates being passed from here, so our out variable will need to go into our fragment shader. So let's add an in variable here. We'll actually get rid of this one, so let's name this one. So we'll do in vec2 text chord. It has to match the name up here. It appears to, it does not. So since I don't have IntelliSense here, usually it's good just to copy and paste, just that way you aren't chasing your tail around trying to figure out why something's not working. And what we need is called a uniform. I'm going to save an entire video dedicated to uniforms. Just know that it's a way for us to also pass data in from the CPU. It just works slightly differently, but in this uniform, we're not going to have to pass anything in. We're just going to specify the texture slot, because once we start getting textures to be more advanced and we might want to support multiple slots, we'll probably have to start passing this in. But for now, we're going to focus on just one texture slot and eventually push multiple textures to one texture slot. So now what we can do is a uniform sampler 2D, so it's a 2D sampler, and we're just saying it's texture 0. So this way we know where it needs to sample from. It's the sampler 2D, and the value is going to be texture 0. So for our output color, well, actually our out vector is just a color, so we just color. We will do it's a method called texture, and we need to be at texture slot 0, and then use the text chords. I'm going to copy and paste this, and then that should be all we need to do. So now, as you can imagine, we're gonna have to change how we're passing the value into our texture here. So let's go into our texture test class here, and we're no longer going to be passing in colors. We're going to be passing in texture coordinates. So let's go ahead and remove these. So we'll remove this red. So our top right, when you think about it, I probably don't have paint still open, but remember the top right would be 1, 1, and the bottom left would be 0, 0. That's where it's a little bit different. So we would want 1.0 and 1.0 F, and that'll be our top right. And then we need our bottom right, which would be, bottom right would be right to the y, so we go right on our x-axis, and that gives us 1, and then 0 on our y-axis, so it would be 0. So here we'll have 1, and then 0, and we'll delete this last one. And then our bottom left would be at 0, 0. So that stays the same. We don't have to change that. And then our top left, which would be 1 on the y-axis and 0 on the x, so it would be 0, 1. 0, 1, and get rid of the third one, and this doesn't need a comma. Okay, so now that we've changed the vertices, how do we tell OpenGL, let's put this in second, ADD's getting, or ADHD, or whatever it is. So how do we tell the, how do we pass this in? Because now that we've changed the data structure, instead of being 6 per vertice, we now have 5 per vertice. Well, it's pretty simple. So very first, we know that the size of it has to change, so we're telling it what is the stride of this. Well, instead, it is now 5 floats. So our position doesn't change. That's at 0, so that we don't have to change any of the offset. And then we also change this down here to 5 because that's still the stride of this. However, we're no longer doing 3 floats. We're only doing 2 floats. So we simply just change this to 2. And then we need to load our texture. So let's create a private instance of a texture here. So we'll do private texture 2D underscore texture. And we'll make use of our resource manager here. So down here, we'll simply do texture equals resource manager. We'll need to bring in that namespace. Dot load texture. And we'll have to obviously pass in a, what's wrong here? Oh, I get it. Yep, because it's singleton. So resource manager dot instance dot load texture, and then we'll bring in a texture, and then we'll have to call texture dot use, so it sets that to the active slot. And since we only are working with one texture slot, we only need to call it once, because we wouldn't want to be changing them on every render frame. But you know, if we start doing multiple textures, we'll have to come up with something for that. But just calling it use once here in the load method is all we need to do, because that's going to just tell OpenGL that's the texture slot we're using. So let's get a texture from the site. We're going to use the learnopengl.com sites. I'll leave a link to their website and also a link to that image. So we just need to drag that in. I'm going to do that now, and it is just going to be a picture of a wall. First, we'll want to obviously have a folder for that. We'll just call it textures. And I'm going to drag that in. File Explorer. Drag, copy that into here. To copy here. And then we'll want to make sure we set it to copy always. And we'll do save all. So we can go back into our test texture, and we need to provide it that path. So that's going to become resources / textures / wall.jpg. Resources textures wall.jpg. And then, of course, we need to load the texture.glsl shader. If we did everything correctly, we should see the wall. Fingers crossed. There we go. Okay, I think we'll call it here for the episode. In the next episode, I have not decided what the next one will be about. I think the two logical areas we need to capture next is we need to know how do we display multiple textures How do we display just part of a texture? How can we create a camera so we can zoom around? And yeah, I think that'll be a next point here. I do apologize. I have not been able to make videos here as quickly as I'd like. Things have just become busy, of course, and this is obviously just for fun for me. It's not a job by any means. But if you have any questions, feel free to drop them in the comments. And if you like what you saw, please like and subscribe, and I will catch you in the next video.